Welcome to Unit 2 AP Calculus AB Test Review. Now this is going to be on Chapter 3, Section 1 through Chapter 3, Section 5. Number 1, let's look at our first problem. Sketch the graph of a function f of x that has the given properties. 1, that f of negative 3 is equal to negative 2. 2, the graph of the derivative is given. And 3, the original function f of x is continuous for all x. So, we need to identify number 1 that this is our derivative graph right here. And what does it tell us? It tells us that this slope is 3 and that this slope is 1. Keeping this in mind, the first thing that we're given in our given information is we have the point negative 3, negative 2. So let's make sure we graph that point. Negative 3, negative 2. Here we go. Next up, as we are coming from the left, we see that our slope is 1. So let's go up 1, over 1, up 1, over 1, up 1, over 1. Where do we know to stop? That's where we need to pay attention. What is our cut point right here? That's at 1. So we're going to keep going with this until we get to 1. Then I have half. Then we realize that from here on we have a slope of 3. So I go up 1, 2, 3, over 1. Second half of my function, and I am rocking and rolling. All right, for example, problem 2. Use the numerical derivative to graph the derivative function for the given function. Secondly, are you able to guess what function the derivative is by analyzing its graph? So if you put this into your calculator, you should get a set of values for x and y such that we see a pattern by seeing 16, 9, 4, 1. I got 3.3e to the negative 7, then another 1. And then if we look at this, we should see that y prime is x squared. Okay, the only one that's slightly off is when we look at 0, but the pattern remains as we look through it. If we were to follow forward, if we kept looking at our table, we'd still see 4, 9, etc. Don't forget about the numerical derivative. For example 3, find the equation for the tangent and the normal to the curve f of x at the given point. So, number 1, what do we need to do? Find the derivative. So, if I'm looking at this, I have quotient rule. I'm going to let u be 3x squared minus 1, v is equal to x. So if I'm looking at this, I have x times 6x minus 3x squared minus 1 times 1 all over x squared. Simplify, and hopefully we see that we get 6x squared minus 3x squared plus 1 all over x squared, which again is 3x squared plus 1 all over x squared. From here, what do I do second? Plug in x to find slope. Okay, so if I do that, keeping in mind what I have y prime is equal to 3 times 1 squared plus 1 all over 1 squared, which is equal to 3 plus 1 over 1, which is 4. So now I have my slope. This is the slope of my tangent line. I have a point. So for my tangent line, all I need to do is use point slope formula, y minus 2 is equal to 4 times x minus 1. And let's rewrite. There we go. And this is our tangent line. What do we need to do if we're going to talk about our beautiful and lovely normal line? Remember that we're talking about a perpendicular slope. So that should be negative 1/4, since our slope for the tangent line is 4. And then we again are going to use point slope to say y minus 2 is equal to negative 1/4 times x minus 1. And this is our normal line. And we have our two solutions. Keep them separate. All right. So that is example 3. We're talking about different phases, being able to take derivatives, being able to apply derivatives, seeing what their relationships are. Example 4. A particle moves along a line so that its position at any time is given by the function where s is measured in meters and t is measured in seconds. And here is our position function. Find the displacement of the particle during the first 2 seconds. Now remember, displacement, plug in. What's the difference? So I have s sub 0, and hopefully when we plug it in we get negative 8. Then I have at 2, when I plug in 2, my hope is you get 0. So from negative 8 to 0 is 8. Or if you think of it as s sub 2 minus s sub 0, I get 0 minus negative 8. So I get 8 no matter what, and that would be 8 meters. Second question. Find the average velocity of the particle during the first 4 seconds. Key, average velocity. So I'm going to find s sub 4 minus s sub 0 over 4 minus 0. S sub 4 is equal to 0 minus negative 8 over 4 minus 0 is equal to 8 over 4 is equal to 2. And don't forget, since it's velocity, that's meters per second. 2 meters per second. Remember, average velocity, we're going to talk about the changes in y over the changes in x. Okay, so v sub average. Next up, what if I change it up on you and say, find the instantaneous velocity of the particle when t is equal to 7? Now, we need to actually find the velocity function, which is the derivative of the displacement. So if we're looking back at our s sub t, we're going to remember that it is t cubed minus 7t squared plus 14t minus 8. Therefore, the derivative would be 3t squared minus 14t plus 14. And then I want to find, we're at 7, so then plug in 3 times 7 squared minus 14 times 7 plus 14 is equal to 147 minus 98 plus 14. Therefore, it is equal to 63 meters per second. All right. Our next part, find the acceleration. So again, we're going to find another derivative. We're going to find the derivative of velocity this time, and we're going to say that this is 16 minus 14. And we want to know what's the acceleration when it's 7. So then I say 6 times 7 minus 14. It's 42 minus 14. And I get 28. And don't forget, since we're talking about acceleration, that is meters per second squared. Meters per second squared. Finally, Describe the motion of the particle. At what values of t does the particle change directions? So if we're doing this, we need to say, where is v sub t? Let v sub t equal to 0. So I need to find the times where we're changing direction. All right. So if I use this, I need to know that I'm going to set 3t squared minus 14t plus 14 equal to 0. That is not factorable. So we're going to use our calculator to get t as 1.451 and 3.215. Now for me, I like making the sign chart to see what's going on. So if I really need to, I could say what's going on. Sorry, put s there and then t there. And I would have 1.451, 3.215, and this is from 0 to 1.451. This is 1.451 to 3.215, and this is 3.215 to infinity. And I'm going to find that if I do this, I have, oops, this is supposed to be velocity. I'm really messing it up. Sorry about that. Positive, 0, negative, okay, and then 0 and positive. If that is the case, then what's going to occur? It said again, at what values of t does the particle change directions? Okay, so the particle starts at 8 meters to the left of the origin and moves to the right. Okay? At 1.451 seconds, it changes directions and starts moving to the left. At 3.215 seconds, it changes directions again back to the right. And it continues until we end. All right, so let's keep that in mind. Keep in mind if you need to use a sign chart that it can be helpful. All right. And finally, find the equation of the tangent and normal lines if we have some trig functions. All right, so now we have trig function and we have a product rule. So we need to make sure we find the derivative appropriately. So hopefully you guys can remember that we're going to do derivative of the second, which is negative sine of x, plus the second times the derivative of the first, so that I get negative sine squared x plus cosine squared x is my derivative. Now this is not Pythagorean because it's not sine squared plus cosine squared, so let's just leave it and then let's find what my slope is at pi over 2. So I have negative sine of pi over 2 squared plus cosine of pi over 2 squared, and I get negative 1 plus 0, so it's equal to negative 1. So for my tangent line, I have m is negative 1, I have the point pi over 2 comma, I need to find y, so plug x into the original function, and hopefully you remember that the sine of pi over 2 is 1, but the cosine of pi over 2 is 0, so we get 0. Now we've got enough that we can find the tangent line by saying y minus 0 is equal to negative 1 times x minus pi over 2. Y is equal to negative x plus pi over 2. And this is our tangent line. Do the same thing